Everybody, welcome to Statistics and Theory. This is Dr. Vahid Aryadus. In this presentation, I'm going to discuss reliability in second language acquisition or second language research. This video is going to have two sections. The first section is about external reliability and the second one is about internal reliability. So let's get started. From the perspective of some authors and scholars in the field, reliability can be divided into two types. One is external reliability and the other one is internal reliability. So let's see what they are. Basically, both of these are about the concept of consistency, and I'm going to talk about consistency a little bit in this presentation. External reliability refers to the consistency of a measurement over time across different test forms and also between raters. The first type of reliability is also known as test-retest reliability, which I'm sure you're familiar with. The second one is also known as the parallel form reliability. That's reliability across test forms. And the last one, which is probably more commonly used in the field of second language research, applied linguistics, and especially language assessment, is known as inter-rater reliability as well. So these are broader categories which are subsumed under the classical test theory, and this was basically a concept that the reliability was a concept that was proposed by scholars such as Spearman, but also other psychometricians. This is about external reliability. There's another type of reliability which is known as internal reliability, which also is known as internal consistency. This type refers to the extent to which items within a test or subscale are correlated with each other. And it reflects a consistency of the responses. And I want to stress this because and I will be stressing this throughout this presentation a few times, that this sort of reliability is about the consistency of responses. It's not about the reliability of the test or the instrument itself. When we establish internal reliability, we have not necessarily confirmed that the items measure the intended construct. In other words, reliability is not an indication of validity. And then by validity here, I mean validity in a traditional sense, which basically refers to construct validity. And there are different types of internal reliability statistics or coefficients, the most famous of which is perhaps Cronbach's alpha or alpha coefficient, but there have been a number of them which have emerged and used throughout the years, including split half reliability, item total correlation, omegas, McDonald's omega, and so on. I will talk about quite a few of them, but I will mostly focus on Cronbach's alpha. Now let's start by focusing on external reliability or external consistency, if you will, and then we will move on to internal reliability or internal consistency. Before doing that, I would want to stress that, again, that although some authors have argued that reliability is a necessary or important but not sufficient precondition for validity, in my view, it may not be necessarily a correct assumption. In other words, you may have evidence for the validity of your instrument, or as they put it in language assessment, the validity of interpretations and uses of your instrument and the consequences. However, the reliability of the test scores that you have collected using your instrument may be pretty low. Now, this is a little bit of a dilemma, and I understand that there are different schools of thoughts on this, and I'm not claiming that my school of thought is the only and the best one in the world. Nevertheless, I wanted to point you to my upcoming book, Assessing Listening in the Age of Generative Artificial Intelligence, where I have discussed basically the concept of validity and also problematized to what extent reliability can be viewed as a subcategory of validity, or to what extent it can be assumed to be related to validity. Chapter 6 of the book talks about that. Okay, when the book is published finally, I will make sure to make an announcement if you would like to be updated about it. Okay, now external reliability. What is external reliability and how we measure it? Well, as I mentioned before, external reliability has at least 3 types. One is the reliability across instrument forms. And the second one is reliability across time, as I mentioned before. And the last one is inter-rater reliability. Let's get started with the first type of reliability, everybody. Reliability across forms has some, or makes some assumptions. Okay, so before defining the this reliability itself, I want to talk about its assumptions. I think the definition is really straightforward and quite self-explanatory. The main assumption of this type of reliability is that when you have 2 forms of the same construct, they are developed based on one theoretical framework or one construct definition or construct specification, and importantly, one set of test specifications. So the construct of, let's say, form A and the construct of form B, as well as the test specifications based on which both of these forms were developed, have to be exactly the same thing. So if you look at this image here, which was generated with the help of ChatGPT, we've got form B and we've got form A, and so both of these 2 forms have something right in common, and that's the construct, meaning that they test exactly the same construct, but also they're developed based on the same test specs or specifications. That's very important. Now, the other point I wanted to add before moving on to discussing this type of reliability itself is that we extended this concept of construct and specification in a paper that was published in Behavior Metrica in 2023, which is called Neurocognitive Evidence for Test Equity and Academic Listening Assessment. Here we have used brain imaging and eye tracking, and we have shown that the psychometric equity of 2 tests does not necessarily mean that there is neurocognitive and behavioral equity across the 2 forms or across the 2 tests. So that's something that I will leave in the comment section of this video, and if you like, you can take a look at it. Okay, now as to the external reliability across test forms itself. It's basically based on the estimation of the correlation between the 2 tests, meaning that you will first of all sum up the scores, and you will get one variable for form A. So this is variable 1, let's say, and then you will get another variable for form B, and let's call this variable 2, and then you will conduct a correlation analysis. Most often, the type of correlation analysis that is suitable for this kind of reliability is Pearson product moment, or just simply put Pearson correlation, because the data are interval. But on the other hand, if the data you feel is ordinal, then Spearman rank order would be suitable. It's the correlation between the 2 forms which are administered to one group of people, and I want to stress that 2 forms administered to one group of people, that gives you an idea about this sort of external reliability, that is reliability over test forms or across test forms. Okay, now that we have talked about this sort of reliability, let's move on to reliability across time. In this kind of reliability, as you can also see from the image here, we have 2 time points. So a test is given to the same group of people. That is this group of people. There's only one group, actually. There's no group 1 or 2. Across 2 time points, the same group of people across 2 time points, that is twice, and then the results of the 2 occasions, occasion 1 and occasion 2, must be identical. There must be no statistically significant difference between the 2, and importantly, there must be a very high, or just high and significant correlation between time 1 and time 2 test scores. So again, Test takers do not change. It's the same thing. And importantly, test forms do not change either. We have to keep them. We have to keep the test form constant. Test takers are also another constant. What changes is simply time. Time 1 and time 2. So we cannot change two things at the same time, because then if we see any variation in the results, we can't really attribute it to the right source that caused the variation that's observed. So this is how we estimate external reliability. Again, we can calculate a correlation coefficient between the two, or if you like, you can do a paired samples t-test to see if there's a statistically significant difference between time 1 and time 2 scores. And then if there is no, that provides some kind of evidence supporting reliability across time. But importantly, you would need to look at the correlation between them, and hopefully the correlation is at least above 0.7. And this 0.7 also applies to reliability across test forms that I just mentioned before. However, as you can imagine, there are two issues with this kind of reliability estimation. One issue is familiarity. We could imagine that the test takers would learn something and become familiar with the test items, and as a result of that, they learn something from time 1 to time 2, because they may remember the test items or the tasks that they were supposed to answer from time 1, and when they're performing on time 2, that familiarity itself can affect their performance. But importantly, they could learn something, because if they're familiar with the items, it means that they remember it. And some of the students, or maybe all of them, they may go out there and read something, or maybe chat with a chatbot and learn quite a little bit about what was tested on the assessment. And on the second occasion, their learning can also affect their performances, and that's a threat to the analysis of the reliability of the two tests. So we need to make sure that first of all, the interval between time 1 and time 2 is long enough so they will not remember the items, but at the same time, we also need to ensure that they haven't learned anything from time 1 to time 2, which is nearly impossible. So this is one of the limitations of this kind of reliability, which we need to take into account. The third type of reliability, external reliability, is known as inter-rater reliability analysis. Here we have one pile of papers representing the performances of students that two testers or two raters are supposed to score. So one pile of paper, one group of students which are scored by rater 1 and rater 2. At least two raters are necessary for this kind of inter-rater reliability analysis, because we know that raters are potential sources of measurement error. If rater 1, let's say, is more lenient compared with rater 2, then the scores that this person gives to the students would be obviously higher. And on the other hand, if one of the raters is more stringent, the scores will be lower. So that's one source of error, which is not attributed to students' performance or students' the construct that we are measuring, or the latent rate that we are measuring. And in this case, that source of measurement error could be detrimental to the reliability of the test, and even to the validity of the interpretations and uses of test scores, or if you will, just validity of the test itself. How do we improve this consistency, the consistency across raters 1 and rater 2, and improve inter-rater reliability? First of all, we need to have a clear scoring rubric. It must not be ambiguous. Preferably, this scoring rubric should be accompanied by some exemplars. For example, if you say that level 1 writing or level 1 speaking performances look like this and that, it's a great idea to present some exemplars so the rater who's being trained can associate the description on the rubric with some real-world examples. That's number one. Number two is we need to do some rater training, some serious rater training and norming, which is also known as standardization, so we could make sure that everybody is on the same page and all of the raters understand the rubrics in more or less the same way, although there will be no guarantee that even after rigorous training and norming, the raters will understand the rubrics in exactly the same way. I was a rater trainer when I was at the National University of Singapore. I was the co-chair of the assessment committee of our center, and I saw this with my own eyes. We had rigorous training and norming sessions, but when we left the training room, the norming room, everybody would almost go back to the default of their own severity levels. Of course, we can address this a little bit with using psychometrics, one of which is inter-rater reliability and the other one is Rasch measurement. Using inter-rater reliability analysis is similar to the two previous types, like I said, with the exception that we have got two raters. But with the two previous types of external reliability, we only use a correlation analysis. If you're more adventurous, of course, you could do some form of general linear model analysis, such as t-tests. And if you have multiple raters, you can run an ANOVA test and things like that. But for this form of inter-rater reliability, I think a correlation coefficient will be just sufficient. Hopefully we will get a correlation of 0.7 and above. I should also add that this is different from rater agreement analysis, in which we want to have perfect agreement with no digression from, for example, an anchor set of score, which is given by maybe a group of raters or committee or even a very experienced rater. That's a different story, and I have covered that in a different video. I will make sure to leave that the link of the video in the comments section. So this is about inter-rater reliability, and finally I wanted to add that there's also a possibility of using Rasch analysis, specifically many-facet Rasch analysis, which was developed by Dr. Mike Lineker. This is one example of how reliability and other psychometric features of assessment facets can work together. For example, here we developed a GPT-powered AI and compared it with human raters, in this case two human raters, and we wanted to see how reliable the scores are. I don't want to go into too much detail here, just wanted to say that we have three facets: participants, raters, and items. If you're not familiar with facets and many-facet Rasch analysis, I suggest that you watch my previous videos. I have made quite several videos about this concept. Each of these facets also has got one reliability estimate associated with it. For participants, we have student reliability, or I mean they're used synonymously. For raters, we've got rater or examiner reliability, and for items we've got item reliability. Now let's focus on examiner reliability, because we're talking about external reliability. We've got a high reliability here, and we've got something which is called separation. In simple terms, separation refers to the number of levels in the severity level of examiners in this case, which are statistically separable from each other, which means that our examiners have been divided into two statistically different levels of severity. And it's very obvious from this map. If you go to the second column under raters, you will see that we have got two groups. Group 1 is GPT and human 2, and group 2 consists of just one of the raters. So we have got two groups. Not surprisingly, we've got 2.49 groups, which can be rounded down to just 2. This indicates that our raters are really different from each other, statistically significantly different from each other, as indicated by the p-value here. An indication that not everyone is functioning in exactly the same way, but also an indication that we need to take into account their differences. So we need to compute their severity or leniency levels and take away its impact on students' scores, on students' standing on this map, which is done by calculating fair average measures in Rasch analysis. I have talked about it in a separate video. You can refer to that video. And also we have some psychometric validity data here, in-fit mean square values and out-fit mean square values. These reliability statistics are credible and useful only if the psychometric validity statistics are an indicator of good and psychometrically defensible measurement. So I will leave it here, and I would like to refer you to other videos to see how I have defined psychometric validity and what outfit mean square and infit mean square values are. Generally speaking, this is how we look into external reliability, specifically inter-rater reliability. Now this is the end of the external reliability. I'm going to continue this to talk about internal reliability statistics, but since this video is getting really longer than I expected, I'm going to do this in a separate video. Please tune in, and I'm going to upload both of these videos very soon. Thank you.